Hello, this is our video series and this is our third part about fundamentals in geometry. In this video, we will talk about rectangular coordinate system. Okay, so when we actually talk about rectangular coordinate system, the first thing that comes to our mind is the intersection of two lines. One is horizontal line, one is vertical line, which is discovered by famous mathematician the French mathematician that is Descartes or Descartes, who was born in France in 17th century. Anyway, invention of this concept is also really interesting, but here we will focus on the use of this concept in solving some, let's say, non-standard or non-routine problems, usually which are asked in math Olympiads. Anyways, these are some basic concepts about rectangular coordinate system. So we use coordinates to represent points in the space. So there are different representing methods and they are called coordinate system. Okay, actually after this method was discovered, it also actually made a huge contribution to the development of the science, especially math, and especially these days, for example, in navigation system, right? They use the idea of coordinate system because every point in the world, right, it has a specific location. So we call this is coordinate system because if you do not introduce any reference points or lines, right, we cannot determine the position of any point in a very, very clear way. So rectangular coordinate system is also called Cartesian coordinate system. In this section, we are going to discuss plane rectangular coordinate system. Okay, this is plane means we are going to position everything just on a surface, like maybe on a table, on a kind of, a flat surface. And that means that it's going to involve only two variables, that is x coordinate and y coordinate. Maybe in the future, and also we'll study actually when but that involves three dimensions, that's x and y and also z. Z is the depth of the point, right? And usually now we live in three-dimensional space, but today we're going to talk about only plane rectangular coordinate system. So the real numbers have one-to-one correspondence to a number line. That means that if you just pick any real number, it corresponds to a unique point on the number line, right? Or if you just pick any point on the number line, it corresponds to a unique real number, okay? One point is not represented by two different numbers. So in a plane rectangular coordinate system, we use two perpendicular number lines, also called axes. That's actually the horizontal line, that is x-axis, and vertical line, that is y-axis. And the intersection point of these two lines, we call this the origin of the coordinate system. The first number represents the horizontal position and second number represents the vertical position. And also actually by convention, okay, so we need to set a rule, right? Okay, the priority belongs to which line? It is x-axis or y-axis. So now here by convention, we are accepting that, okay, to move from one point to another point, first we need to move along the horizontal line. And after that, a vertical line, okay? So that means that if we represent any point in the coordinate system by an ordered pair of two numbers, the first number represents the x-axis or the position of point on the x-axis, and the second one is the position of the position of the point on the y-axis. So the two axes divide the plane into four quadrants. They are named quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Anti-clockwise, the axes are not included in any quadrants. Okay, simply we are saying that here, since our coordinate system is okay. Why is that writing? All right. Just a second. Okay, all right, nice working, good. So we are talking about this. Let's say this is our y-axis, the vertical line, and this one is our x-axis. So this x-axis and y-axis. As you see here, when we just introduce these two lines to our plane, right, it looks really beautiful. Now, immediately, actually, you can just if I plot any point, immediately you can just compare, right? This is our origin, right, and how is it located? And also to read this position, first, I need to walk along the x-axis until we reach the shadow of this point on the y-axis, right? And after that, we just walk parallel to the y-axis until we meet this point. And let's say this point is x, and it's represented by a pair of ordered pairs. So x represents a point on the x-axis, and y is on the y-axis. So again, here we are saying that when we just wrote these two lines, right, it is dividing this plane into 4 sections. So the first part starting from the x-axis in anti-clockwise direction, this is called the first quadrant. And this part is the second quadrant, and third quadrant, and the fourth quadrant. Okay, and since this is the origin, right, the origin, so if you just move to the right along the x-axis, actually all numbers or all points are represented by positive numbers. If you move above, right, along the y-axis, then actually they are all the points on the y-axis are represented by positive numbers. To the left, negative, and the bottom or down, it is negative numbers. So all right. So this is our coordinate system. As you see here, some points are labeled here. Point A, for example, the coordinates of point A, that is 2, 3, right? First, we need to write is x coordinate, that is 2 and 3. And coordinates of 3, 2, for example, let's say this is our point, and another point, let's say this P, for example, okay? And the point C, let me write here point, this one is B, and point C, and this one is point D, and this one's point, okay, we have already point B. We just write here A, B, and the origin C, D, and let me just write here point E. And this one is point F, right? As you see here, point A and point E, they belong to the first quadrant because it's both coordinates are positive numbers. Now, if you look at point F, for example, x coordinate is negative 4.5 and the y coordinate is 5. So x coordinate is negative, that's why it belongs to the second quadrant, and y coordinate is positive. If you look at the point B, for example, it is in the third quadrant, right? So it is x coordinate and y coordinate, both are negative numbers. And how about D? X coordinate is 0, that's why it's on the y axis. And point C, it is on the axis because it is y coordinate is 0. Okay, these are just some basic concepts and terminologies about coordinate system. So immediately let's see them in a few examples. And after that, we try to solve some questions from exercise 3. In this question, the point P, whose coordinates are A and B, is given on a plane where P is lying in when AB is greater than 0, AB is equal to 0, AB is less than 0. That means that we need to determine the position of P, right? It belongs to the first quadrant, second quadrant, or it is lying on the x-axis or y-axis, nothing. So if you look at the first question, here we have question A, and A times B is greater than 0. And the previous videos, we already actually investigated this situation, right? We know that the product of two real numbers is positive if and only if they have the same signs. So that means that here we have two conditions. So the first case is either A is positive and B is positive. That means that P belongs to, what is it, quadrant 1, right? Because both coordinates are positive. And how about if A is negative and also B should be negative at the time, X coordinate is negative, Y coordinate is negative. That means that the point is lying in quadrant 3, right? So here, this is our coordinate system. Okay, this one is our first and this one is our third quadrants, right? So P is somewhere here, let's say, because both coordinates are positive, or it is here. Okay, so we have two possible cases here. And how about for question B? For question B, AB is equal to 0. A times B is equal to 0. So that means that A should be equal to 0 or B should be equal to 0. That means that if the product of two real numbers is equal to 0, let me just write this one, it means and. That means that at least one of them must be equal to 0. Both of them can be equal to 0, doesn't matter. So now again, if A is equal to 0, so that means that coordinates of P will be something like this. Here we have 0 and B. B can be anything. So at the time x coordinate is equal to 0, this point belongs to the y-axis, right? It is on the y-axis. And how about the second case? If B is equal to 0, at the time the coordinates of P will be, here we have A, and B is equal to 0. A can be anything, right? A can be 0, A can be 5. Okay, we don't have any restriction on A. At the time, this point P will be on what? On x-axis. Okay. In the third example, the product of the coordinates of these points, right? Let's say this, okay, let me use not blue, let's use green. Okay, C, in part C, A times B is less than 0. So that means that A should be equal to, should be less than 0, and B is greater than 0. Because if the product of two real numbers is negative, that means that they need to have opposite signs. Or, let me just write here, or A should be positive and B, okay, B should be negative, right? So if A is negative, B is positive. Where is it? If you remember from the previous slide, right? X is negative, that means it is to the left of x-axis, and B is positive, means it's above the x-axis. So at the time this P, right, the coordinates of P will be in what? In quadrant 2. And how about here? A is positive, that means that the point is lying on the right-hand side of the y-axis, and B is negative, that means that the point is lying below the x-axis, so the point P will be in quadrant 4. Okay, that's very simple investigation about the position of a point where the coordinates are, the product of these coordinates are given, right, differently. Anyway, let's move to another question. How many, we have two questions here. Question A, squares. Question B, right angle triangles can be formed by using the points A, B, where A is equal to 1 or 2 or 3, and B is equal to 1, 2, or 3 as vertices. So if we just actually suppose that we are given here 1, 2, 3, that means that A, it can be 1 or 2 or 3, right? So suppose that it's x-axis, actually it represents our A, so it can be here, either it is 1 or it is 2 or it is 3. And how about the coordinates of B? Also it is either 1 and 2 and 3, right? So actually, how many different points I can write here? I can write 9, right? Because here we have 3 possible choices here, and also for B, 3 times 3, that is 9. It's like 1, 1, 1, 2, 1, 3, or 2, 1, 2, 2, 2, 3, or 3, 1, 3, 2, 3, 3, right? So number 1, let's talk about the number of squares. So to find the number of squares, as see here, how many different types of squares can I form here? So actually here I can form 1 by 1 squares, or 2 by 2 squares, and 3 by 3 squares, right? We have, I can form 3 different 3 squares with different 3 different squares with different length, or let's say 3 squares of different length. So how about 1 by 1? Let's see here, 1 by 1, either, let me just write here A, B, E, D. Let me just put a dot in the center of the small square. Okay, that's here 1 or 2 or 3 or 4 or 5 or 6 or 7. Actually, these dots must be the vertices, right? So we have only the things. It is either ABED or DEHG or BCFE or EHIF. So how many squares I can have? I can have only 4. So now if we are talking about 2 by 2 squares, right? How many? We have only one. 2 by 2, we have only one. So that is only 1, right? And that is 4 and 1. So 1 by 1 and 2 by 2, 1 by 1. 1, 2, 3, 4. And 2 by 2, it is okay. 1 and 2. All right. So all right, good. And also, actually, I can form another square here, right? If we have when it is actually the area is equal to 2, for example, can the area be 2? I think I better count this in terms of the area, because first, if the area, let's say, and the number of what is it squares, because here I can find 1 centimeter or 1 unit squared. Square that is 4. When it is 4, I can find 1. But actually here, all these grids are squares, right? I can form another square here. Let me just draw a straight line here. Okay, brown. And how about if I join these points? Let's say this one, and also this one, and also this one, right? And also it's also square, right? And this is also another square. Okay, can I form in a different way? No. And what is the area of the square? Actually, the length of each side here, right? This A, B, B, C, they are equal to 1. So using the Pythagorean theorem, actually we can find this length is equal to square root of 2, square root of 2. So what is the area here? And also I can form one square whose area is 2. How many? It is 1. So altogether, dot, 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 actually we can get how many squares? We can get 6 squares. Or I can form 6 squares where the vertices of these squares are these given points, right? Okay. And how about the triangle? Actually, for the right angle triangles may have area but different shapes, right? So that's why it's not a suitable way to count the right angle triangles by area. But instead, okay, usually to form a right angle triangle, one angle should be equal to 90 degrees. Okay. For the second case, let me delete my drawing and oops. All right. With my drawing and focus on the second question. Mateo, are you in this class? Okay. So how do you count this then? So where we can form right angles. For example, here, suppose that if we form the right angle at the position where actually is it is at the points A, right? The first one is, let me change the color here, A and C and G, where's G, and I, okay? For example, if we just form this, for example, how many right angle triangles we can form whose area is 1/2, right? So if it is so, number one is, let me just show this, is it's either this, right? Or this, or this, or this, right? And how many we can form? 1/2, I can form 4 right angle triangles, right? And how about the right angle triangles whose area is 1? For it is to be 1, right? For A, for example, 1 is this, right? Or another one is also this, right? So at A, we have 2. In similar way, at C also, I can form like this 2. At I, it is 2. At G, it is 2. So how many? We have 4 times 2. I can form 8 triangles because all of these points are symmetric, right? Along the line x equals 2, along the line y equals 2. That's why. And how about 1 over 2? Where, okay, here ACGI, right? 1 over 2 again. So, okay, we have already 4 and okay, 1 over 2 and 1 and actually it is not 1 over 2. This should be equal to 2 because we have already counted the areas, triangles, right angle triangles whose area is 1 over 2, right? How about 2, for example? Let's say if our right angle is at A to be 2, right? It should be this, the biggest right angle triangle here. Okay, how many I can form here? 1, since it is right angle is here. That's it. We have only 1. So if I just draw from here, right angles here, it is 2. Here it is 3. It is 4. So we have 4 right angled triangles. Okay, we are done with this. And second case is, how about if the right angle is at B? Let's say it is at B and the D and the F and the H, right? So at the time, can I form right angles whose area is 1 over 10? Okay. Again, I see as they are symmetric, right, about the point E. That's why just I need to count 1 and multiply by 4. For example, if our right angles at D, how many triangles I can form whose area is 1 over 2? So I can form just, what is it? This one, right? And it is 2 times 1. It is 2, 1 over 2. So, okay, not like this. I think I can form like this. It is 1, right? Or this one is 2, right? So any other one? No, I can form only 2. So we have such 4 such points. So 4 times 2, I can form 8 such triangles. And how about if the area is 1, right? So if it is 1 at the time, I can just draw like this. No. It is at, what is it? Okay, D, right? We're talking about D. Okay. So D angle should be 90 degrees and area is 1. So that is, let's say like 1, right? 1 or 2, like this, right? Do we have any other right angles like this with 1 over 2? VDF 1 over 2. Okay, 1. Okay, 1 times 2 over 2 and 1 times 2 over 2. Okay, also we have this one, right? Because if I draw this line, let me draw with annotate. Okay, how about this one? How about this one? And also it's also right angled triangle, right? Because now this angle is 90 degrees. Okay, so we have 3 then. Here actually I can form 3 different triangles where the angle D is 90 degrees. And we have such 4 points. So here we have 4 times 3, that's equal to 12. Okay. All right, so we are done with this point. Only 1 point is left. That is, what is it? Point E. So for point E, if the point is here, right? How many different triangles whose area is 1 over 2 and 1? So 1 over 2, if it is 90 degrees, what is it? I can form this one, 1, right? And another one is 2. Another one is here. It is 3. Another one is here. It is 4. Okay, so we can form 4 different triangles. How about if the area is 1 at the time? The only way is, what is it? It is 90 degrees. So I can form this one. In a similar way, I can form this one, right? And I can form another one here, and I'm 1, 2, 3, 4. So we can form 4. So now if you just add all of this number, that's it. I think we just counted all of these points, right? It is 4, 8, 4, 8. So it's 12 to 24 and 36. 36 plus 8, that's equal to 44. So the answer is, for question part B, we can form 44 right angle triangles whose vertices are 3 of these points, right? And where area is not important. Actually, we can just form this many right angle triangles. Okay, another example. A turtle is walking from 0, 0 to 0, 1, and after from 0, 1 to 1 to 1, 1 and 1, and from 1 and 1 to 1 and 0, and from that point to 0 and 2, 2, and 0, 2, and 0, 3, 3, 3, 3, 0, 4, 0, 4, 4, and sequentially. So in this pattern, actually just following some kind of pattern, and maybe this drawing some kind of art. Okay, anyway, so the question here is, find the distance traveled by the turtle when it walked to 5, 6, okay, to the point whose coordinates are 5, 6. And question B, find the position of the turtle when it had walked 2008 units. Okay, in this kind of questions, usually, especially in general and geometry questions or coordinate geometry, right? Drawing really helps a lot to visualize the problem, right? To understand even, okay? And that's why we need to draw the picture and see what's going on here. So if you just draw our coordinate system, and that is the path of this turtle. Now the first position is see from 0 to, and this one is 1. Okay, this point is, let's say this 1, and this one is 2, this one is 3, and this one is 4. And this one, let's say this 1 unit, it's 2, and 3, it is 4, right? First, when it just moves from 0 to 1, and 1 do this, and 1, 1, right? And after from 1 to 2, and 2, and walk up and left, up, right, down, right, up, left, blah, 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 right? So what is the question here? Find the distance traveled by the turtle when it walked 5 to 6. So to do this one first, let's just make some observation. What's going on here? So for example, when turtle walks, let's say from 0, 0, 0 to 0, 1, or if its position is at 0, 1, right? Not 0, 1, let's say it is 1, 0. Okay, because it's 0, 1, it's already 1, we can see that. And when it is position is 1, 0, right? And how many points does it go through here? So this is the first point, right? The second point, third point, fourth point. So it passes through 4 points, right? Now, what is the distance traveled by the turtle? The distance traveled by the turtle since 4 points, and from 1 to 4, right, how many intervals we have? 3. So that is 1, 2, 3, right? So actually, it travels 3 units. Now, how about if its position is at 2, 0, for example? Not 2, 0. Let's say if it is 2, 0, it's just, what is it? It's just 2 square, right? However, if it is 0, 2. For 0, 2, we will continue, right? Here we have 3, 4, 5, 6, 7, 8, right? So it travels 8 units, right? That means that if its position is at 0, 2, that means that the turtle has already traveled 8 units. And in this way, for example, how about if it is again going up, right, and come back? And if it is at 3, 0, for example, let's say here we have 3, 0, okay? As 3, 0 again, what is it? It is, here we have 8, 9, 9 plus 3, and plus 3, that's equal to 6, right? It's 15. So the distance traveled by the turtle is 15. Okay. So actually, when actually the numbers on the y-axis, it is even, right? Let's say this one is not even. Let's say it is, okay. All right. So this one is odd number, and this one is odd number, right? And here it is even number, and it is even number, right? So when it is actually 2, because if it is even number, it is moving up. If it is odd number, it's moving to the right, right? On the x-axis, if it is on the odd number, then it's walking along the x-axis. If it is even number, it's walking up, or actually the line anyway, it's moving up. So from here, what conclusion can we draw here? So here, let's say its position is on the x-axis. On the x-axis means, let's say it is somewhere here, n0. And also here, let's say that n is even. Okay, now what will be the distance traveled by the turtle? As you see here, this 3 is, what is it? It is 2 squared minus 1. 8 is 3 squared minus 1. 15 is 4 squared minus 1. At the time, the distance traveled by the turtle will be n plus 1 squared minus 1. Okay, so I see here, if it is, so here it is even, right? If it is at 2, right, what is the distance traveled? Okay, when it is actually, all right, so n0, it should be odd, right? Because on the x-axis, it should be odd. Okay, so because it's 1, it is, the distance is, it is 3. So it is 3, it is 2, 1 plus 1 is 4, 2, 2 squared minus 1, that's equal to 3. So second one is, how about if its position is at this point, 0m? And 0m is, it is on the y-axis, and suppose that m is here, it is even, right? As see here, it's even 2 or 4, right? When it is at the position of even number on the y-axis, then it's not walking to the right, it's walking up. If it is an odd number, then it's just walking to the right. Even if it is odd, actually, I can get the formula, because just I'm choosing here when it is even. It actually doesn't matter. Here, what is the distance here? Distance here is, what is it? 8, right? That's 3 squared minus 1. So that's equal to m plus 1 squared minus 1. Okay, so just remember that if it is an even number on the y-axis, from that number, we should move up to another odd number. If it is an odd number, then it should walk to the right. On the x-axis, if it is an odd number, it should walk along the x-axis. If it is at even number, it should walk up. All right. So now, using this idea, let's answer the question. Here the question is, find the distance traveled by the turtle when it walked to 5 to 6, right? So first, actually, as you see here, this 5 is odd number, x-axis, right? So it is odd number, and 6 here it is even number. For first, if I find this position, for example, let's say now the turtle is, okay, the position of the turtle is here, it is 0. Okay, it is, let's say it is 0, 6, right? And 6 is even number. So then what is the distance traveled by this turtle? Distance traveled by this turtle is 6 plus 1 squared, right? Minus 1. So that's equal to 7 squared, 49 minus 1, that's equal to 48, right? So here it is actually 60 means, let me draw here. Okay, here we have actually 6, right? And it is here. And suppose that here we have 5. All right. So now as see here, when it is even number, right? After that, it moves to up. It moves up actually, because from even number, it moves up. If it is an odd number, it moves to the right. So now from 6, just draw a bit longer. Okay. And now it moves to here, right? It is 7. And after that, it moves 5 units to the right. So that will be 5, 7. Okay, no, it will be, what is the question here? 5, 6. Okay. All right, all right. So actually here it is coming from this direction, right? Because it is even, right? For even number, the turtle is walking in this direction. Okay. So that means that what is this number then? What is the position of this number? Let's say this P. Okay, that is 5, right? And when it is 6, it walks 48 units. Now we need to walk 5 units backward. So that means that 48 minus 5, it will be 43. So the answer to this question, when the turtle is at the point 5, 6, right? The distance traveled by the turtle will be, what is it? 43 units. Okay. And how about the second question? Find the position of the turtle when it had walked 2008 units. Okay. And also here, all right, I need to find a number that is close to 2008, a square number, because to find the distance traveled by the turtle, right, we are using one of these formulas, right? So suppose that now the turtle is at the point, for example, let's just solve this. This is part A. Okay, it took a lot of time, but no problem. Let me draw a line here and solve the second part here. Okay. So if the position of the turtle is, let's say, at 43 and 0, right? So 43 is an odd number, actually. So the distance traveled by the turtle will be 43 squared minus, it is 43 plus 1 squared, right? 44 squared minus 1. So that's equal to 44 squared minus 1 is 1936. Okay, 1936 is a perfect square number, which is equal to 44 squared. And how about if it is at the position of, because now it's at odd number, right? When it is odd number, actually, after odd number, it moves to, what is it, even number. Anyway, so odd number, if it is at 44, 0, okay. So that's 43, 0 is on the x-axis, right? On the x-axis, if it is at the odd number, after that it moves along the x-axis to another even number. So it is 44, right? So the distance travel will be just one more than this. So that's equal to 44 squared. That's equal to 1936. Okay. So still it is on the x-axis, right? 44, 0. So now it moves up, right? So 2008. So how about this 44 and 44? Because now at 44, right, it moves up 44 units after the turn left towards the x-axis. So the distance travel will be, here we have 1936 plus 44, right? So that's equal to 1980, right? So now to come to the point, 2008, right, we have 28 units. So now it should walk to the left, right, to the left 28 units. So that means that 44 minus 28, 44 minus 28, it will be 16. So the distance will be, what is it, 1980 plus 28. So that's equal to 2008. So when actually the turtle has walked 2008 units, it will be at the position where the coordinates are 44 and 16. Okay, next question. Example 4, it's about a parallelogram. So here it says that point A, B, C, and D are the vertices of a parallelogram. Find all possible positions of D. Okay, usually in geometry, when you are labeling the vertices of any polygon, it should be in alphabetical order. All right, for either it is A, B, C, D, or in clockwise or anti-clockwise direction. Usually, for example, if you're talking about a square, let's say here we have a square, I cannot label this like this: A, okay, B, and C, and D. Okay, that is otherwise actually it causes some confusion. That's why by convention, when you are labeling the vertices of a polygon, we need to label them in alphabetical order, either in clockwise direction or anti-clockwise direction. But in this question, okay, usually we should ask questions without giving any what is it, labels. Actually, we should not label the vertices so that we don't actually have any confusion. But anyway, in this question, it's already labeled, so you should just ignore this rule for this question. So in this way, after that, if I just plot these points, A, -2 to 2, so it is somewhere here in the third quadrant, and B, -1, 2, that is somewhere in the second quadrant, right, AB, and C, it is 2, 0 is on the x-axis. So at the time, if you are going to draw a, what is it, parallelogram, right, the only way is here A, B, and C, D should be somewhere here, right, it's somewhere here. Okay, so we have only possible answers. But here, if I ignore A, B, C, right, at the time we have some two or three different possible answers, because here D can be opposite the angle A, right? Or D can be opposite the angle B, and D can be opposite the angle C. So we have three different possible points. And if you just join all of these points, actually we will have three different parallelograms. Okay, if we just ignore these labels. So for this question, I'm going to ignore. Suppose that let's say we have point 1 and point 2, point 3. Point 1, it is point A. Point 2, it is point B. And point C, it is point 3 is point C. So now let's start with the first one. Suppose that D, actually angle D, is opposite the angle A. So our first case here is, suppose that angle A and the angle D, they are faced opposite to each other. Okay. So at the time, D will be somewhere here, right above here. So to draw this one, let me just draw and okay, at the time here we have AB, and here we have BC, right? So the orientation to go to C, right? I need to walk like, what is it? 1, 2, 3, 4 units, right? And after that, 2 units. So here we have the same thing: 1, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2. So actually it should be all right. No, to go to D, okay, first we should go up, right? 1, 2, 3, 4, and 1 to the right. So that is 1, 2, 3, 4, 1 to the right. It will be here. So this is the position of D. That's the first answer. Let's say it is D1. Okay, whose coordinates are, what is it? It is 3 and 4. So that is 3 and 4. Okay, if D is opposite B, at the time the answer will be, the coordinates of D will be, what is it? 3 and 4. So in the second case, now suppose that D is opposite C. So D is, angle D is opposite to C, angle C, right? So at the time, let me erase and redraw this. Okay, let me use blue here. So at the time, we will have this kind of parallelogram. Okay, here we join these points and these points, right? To go to D, right, it's opposite C. First, okay, from C to B, right? I should walk 2 units up and 1 to 3 units to the left. So to go to D, then I should go 2 units up, 1 to 2, right? And 3 units to the left, 1, 2, 3. So it will be somewhere here. So what is this coordinates? 1, 2, 3, 4, 5. So the coordinates of D will be -5 and 0. So now if you just draw this, you will get this shape. Okay. That's our parallelogram. Right? Opposite sides are equal. So that is the second possible position of D. So let's say this one is D. Okay, whose coordinates are 5, 0. And another option here is, what is it? A, B, right? C, and D is opposite B. So the third case here is, suppose that angle D is located in the opposite side of angle B. Angle B we have already done, right? Oh, angle A, no, the first one should be D, right? Angle A, angle D, and this one is angle C, angle D, angle C, and angle D. And third one is angle B and angle D. Okay. And the third one, if it is so, right, at the time we will have again, so what is it? Angle B, it is somewhere here, right? So to go to C, B, for example, okay. So from B to C, right? Because AD should be parallel to BC. We should walk 1, 2, 3 units to the right and 2 units down. So from A, it is 1, 2, 3 units, right? And 2 units down, 1, 2. So it will be here. It's the third possible position of D. So coordinates of D will be, it is 1 and 1, 2, 3, 4. That's equal, that's -4. 1, 2, 3, 4. Okay. So now if you just join the points, you will see how it looks. We have, and here we have. Okay. All right. Of course, this is actually solving this problem by drawing and using the coordinates. Okay. So in general, all right, how do we solve this without drawing? Also, without drawing, we can solve this using like straight line equations or the midpoint or blah, 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 or also using the orientation. Let's see, for example, if suppose that ABCD is a parallelogram and D is opposite B, right? And BC and AD, they have the same orientations, right? So how can I move from B to C? Actually, I need to use the same, we call this vector in math. We need to use the same orientation to move from A to D, right? To move from B to C, I need to walk how many units? It is 2 minus minus 1, that is 3 units to the right, and 0 minus 2, that's minus 2, 2 units down. So if you just apply the same orientation for moving from A to D, you will actually, it takes us to the point D. Okay, another example. Example 5, M2 minus 1 is a midpoint of A and B, where the coordinates of B are -4 and 7. Find the coordinates of A. Okay, but usually, again, if you're given any straight line, okay, here, let me just draw any straight line, and let's say this point is A and this point is B, and coordinates of B, it is -4 and 7. And how about A? A, I don't know. Let's say coordinates of A, it is A and B. And this one is the midpoint. Okay, let's say the midpoint, whose coordinates are, it is 2 minus 1. Okay. So now to reach this M, right, from A, for example, okay, I need to walk like some units in the direction of x-axis, then in the direction of y-axis. If I use the same thing, right, for M, from M, for example, to the right, like M units and N units up, it will reach B, right? So we just use this idea. But in general, we can show that here, right? So if you're given any 2 points, let's say this is point A, whose coordinates are x1 and x2, and let's say we have another point B, whose coordinates are x2 and y2. And how about the midpoint? Here, these line segments are equal. The midpoint will be x1 plus x2 over 2, and y1 plus y2 over 2. Okay. So the proof is very simple, all right, but here, let me just prove this, and for other questions, I can use this formula. So let's say this one is y-axis, this one is x-axis. And suppose that we are given any line segment, okay? These coordinates are A and this B, and coordinates of A, let's say it is x1 and it is y1. And coordinates of B, x coordinate, it is x2, and y coordinate, let's say it is y2. So here our problem is to find the midpoint of this line segment. And suppose that this is a midpoint, okay, let's say this M, all right. To find the midpoint, now I'll just draw a parallel line to the x-axis that passes through the point Y, and also parallel line to, what is it, y-axis that passes through the x-axis. And also another point from M, okay? And see here we have 2 similar triangles. So here AM, let me just label this by H, okay, this one is AB. Let me just label this by C. The triangle AMH is similar to triangle ABC. And since we are expecting that, we are actually, is given that this AM is equal to MB, right? If you draw a parallel line, also it must bisect this line segment, okay? So from here, and also actually this MH is half of BC. So that means that how can I find this midpoint? So this line segment is equal to this line segment. If this coordinates of this point, let's say is x, right? How do you find this? Since this distance is equal to this distance, that means that here we have x minus x1. That's the distance between x1 and x, and that's equal to x2 minus x. That's the distance between x and x2. Now, if you just solve this for x, you will get x1 plus x2 over 2. Okay, so now from here, I can find this m. Then m coordinates, right? X is equal to, let's say, actually this M is given here. So 2, okay, 2 is equal to, right? It is A plus negative 4 over 2. So from here, A is equal to 2 plus 4 plus 4, that's equal to 8. And second coordinate is negative 1 equals B plus 7 over 2. So from here, B is equal to minus 2, that's equal to minus 9. So coordinates of A are 8 and minus 9. Okay. How about in this question, M is the midpoint of A and B, find the coordinates of M. So the coordinates of M, suppose that it is X and Y. So X is equal to negative 7 plus 5 over 2, that's equal to negative 1. And how about Y? It is 3 plus 11 over 2, that's equal to 7. So the coordinates of M will be negative 1 and 7.